Alright, we're going to solve this inequality, absolute value inequality. You treat it the same way as an equation sign, with a little twist. You do 2x minus 9 is greater than 1, except the other one is going to be 2x minus 9 is less than or equal to negative 1. So besides just changing the answer to a negative, what else did I do? I flipped the sign. Okay? And now we solve. So we're going to add 9 to both sides. Add 9 to both sides for both of these. This one's going to be 2x is greater than or equal to 1 plus 9 is 10. And 2x is less than or equal to 8. We want to finish this off. We're going to divide this by 2. Does the sign flip? No, we did not divide by negative, so the sign stays the same. Here we divide by positive 2. Okay. We also want to do a number line answer. Whenever we do inequalities, we want a number line answer. So let's put 4 right here and 5 right here. I'm not picky on being exact. And I want to graph this. So, will the dot at 4 be open or closed?
Closed.
It's closed. And according to this, am I going to go left or right? It's less than or equal to 4, so doesn't that mean this way? And for the 5, it's also closed. And which way am I going? Follow the arrow. Greater than or equal to 5. Now, that is your graph. That is the answer, except this is an OR. There's something you're going to learn about ORs and ANDs. This is an OR problem. It's either x is greater than 5 is the answer, or x is less than or equal to 4. It's those two answers. And it's very important you put that word OR there. ORs will always go in opposite directions. Here's another problem. We first need to isolate the absolute values. So the first step is going to be to minus the 6 over. What will be the next step? Divide by 2 to get rid of this. Don't drop the absolute value yet. What's next? Does this look like this? So create our two problems. 2 minus 3x is less than 9 is our original. Our other one is going to be 2 minus 3x is greater than negative 9. And we're going to solve each of these, just like we did here. So we minus the 2. This one's going to be negative 3x is less than 7. This one's going to be negative 3x is greater than negative 11. And then we have to divide by negative 3. My answer, x. Do we switch to sign? Yes, because we divided by a negative. And my other one, do we switch that? Because we divided by negative. So that becomes a positive 11 over 3. Now, make our number line. Negative 7/3. I don't care exactly where it's at. Negative 11/3. Is this an open or closed circle?
Open.
Because it's just greater than, it's an open circle. Greater than, so if at negative 7/3, which direction will I shade? Greater than, follow the arrow. Does that mean I'm going to go this way?
Mm-hmm.
And for this one, which direction am I going for this one? Left. So your answer is in between. Everything between those two dots. Now, this one is called an AND because it's both answers. Whenever it goes in between, it's an AND. And you have to write your ANDs in a certain way. You must write your ANDs like this. You have to write your answer like that. What that is saying, x is between negative 7/3 and 11/3. Right there. Another way of describing that, if I cover this right here, do you see that right there? If I cover this, do you see this right there backwards? This is this backwards. It's a compound inequality. You have to write your ands in this form or else it's wrong. Ors can be written like this. You're good. Ands have to be written in this form. They always are graphed in between. Ors are always graphed out. Now, there is a trick to remember if it's an and or an or. Besides looking at the graphs, you can look at the graphs and tell it's an and or an or. Ors are out, ands are between. But right from the beginning, you can always tell if it's an and or. Here's how. That is a great or, spelled wrong. This is a less than. Less than and greater or. Greaters are always or, less thans are always ands. It's the easiest way right off the bat to tell if it's an and or. Awesome. Very short, helps out a lot.